So for prompt 1, basically 2 alpha helixes can generally be held together with disulfide bonds, ionic bonds, or hydrogen bonding. For this case, the 2 alpha helixes are interacting via 2 major mechanisms: electrostatic interaction and hydrophobic interaction. Electrostatic interactions are also known as van der Waals interactions. They are the attract or repulse interaction between objects having electric charges. And hydrophobic interactions they describe the relations between water and low soluble water molecules. The first mechanism is the electrostatic interaction, and it is between the positively charged ammonium ion side chain on the lysine with an acid side chain on the glutamate, which is negatively charged. The other mechanism is the hydrophobic reaction, and it is by the hydrophobic core of the alpha helix with the isopropyl side chain of the lysine amino acid. The isopropyl group can interact with the hydrophobic core via the van der Waals forces. The basic purpose behind the hydrophobic interaction is that it will increase the stability of the complex when the hydrophobic amino acids are well protected from the surrounding aqueous media, and hence, as a result of this, the hydrophobic molecules will then come together. The basic principle behind the electrostatic interaction is that basically opposite sides will attract each other. I actually found 2 residues or amino acids that could replace the lysine, and my first one that I chose is isoleucine because it can maintain the stability of the core, and it is equally hydrophobic as lysine with the same chain length and molecular mass. Also, the R groups are isomers of each other. The other one, which basically an amino acid that can replace lysine, in my opinion, is phenylalanine, because without destabilizing the molecule, it won't destabilize the molecule. This is because phenylalanine has a hydrophobic side chain, which basically it has an aromatic benzene ring with a methyl group attached. This can then interact with the hydrophobic core with the van der Waals interaction. An amino acid which can destabilize, if replace the position of lysine, is basically any polar amino acid, such as histidine, glutamic acid, aspartic acid. The polar side chain of these amino acids cannot interact with the hydrophobic core. Any hydrophilic residue can destabilize the core by breaking the hydrophobic interaction present. As the surrounding medium is aqueous, the hydrophobic amino acids would prefer to be exposed to the medium rather than being clubbed to each other. Hence, the serine, threonine, and aspartic acid, and etc. These can all destabilize the core. For prompt 2, the side chains of any pair consisting of basically one acidic and one basic amino acids will interact like lysine and glutamate. For example, asparates and arginine will do the same thing, and asparates and histidine will do the same thing.